Welcome to Copernicus AI, Frontiers of Science. I'm Matilda, and today we're diving into the fascinating world of swarm intelligence and collective AI systems. It sounds like something straight out of science fiction, but Adam, our expert on AI and complex systems, assures me it's very real and rapidly evolving. Adam, what makes this research so revolutionary?
Thanks, Matilda. It's a pleasure to be here. When we talk about swarm intelligence and collective AI, we're really talking about a fundamental shift in how we approach problem solving, moving away from centralized, top-down control to decentralized, emergent behavior. Consider the recent work by Nicholas Cook and colleagues titled Collective Decision-Making by Embodied Neural Agents. Their research, available on PubMed, explores how simple social interactions within multi-agent systems can lead to surprisingly effective collective decision-making. This is revolutionary because it challenges the traditional AI paradigm of creating increasingly complex individual agents. Instead, it suggests that intelligence can emerge from the interactions of many simple agents.
That's fascinating. So instead of building one super smart AI, we're building lots of not-so-smart AIs that somehow become intelligent together? How does that actually work in practice?
Exactly. Think of it like an ant colony. Individual ants aren't particularly intelligent, but the colony as a whole can solve complex problems like finding the shortest path to a food source. In the AI context, this involves designing agents with simple rules and allowing them to interact with each other and their environment. For instance, researchers might use reinforcement learning to train agents to perform specific tasks and then allow them to communicate and coordinate their actions. The magic happens in the emergent behavior, patterns and solutions that arise from the collective interactions of the agents.
So what are some of the key challenges in developing these kinds of systems? It sounds like it could easily become chaotic.
You're right, controlling and understanding emergent behavior is a major challenge. Another one is ensuring that these systems are robust and adaptable to changing conditions. As Hao Kui and Taha Yasseri point out in their 2024 paper, AI-Enhanced Collective Intelligence, available on Archive, current societal challenges are exceeding the capacity of humans alone. Their research highlights the complementary capabilities of humans and AI, suggesting that AI's role will vary from assistive tools to participatory members in human collectives. The key is finding the right balance between human oversight and autonomous AI decision-making.
That raises an important ethical question. How do we ensure meaningful human control in these AI-driven collectives? It sounds like it could easily get out of hand.
That's a crucial concern. Luciano Cavalcante-Siebert and colleagues addressed this in their 2021 paper, Meaningful Human Control, Actionable Properties for AI System Development, also available on Archive. They emphasize the importance of designing AI systems with properties that allow humans to retain control, even when the system is operating autonomously. This includes things like transparency, explainability, and the ability to intervene and override the system's decisions. We need to move beyond simply building intelligent systems and focus on building responsible intelligent systems.
This also seems closely related to the study of human social networks. Are there lessons we can learn from how humans collaborate that could be applied to collective AI systems?
Absolutely. There's a lot of cross-pollination between the study of human and artificial collectives. For example, research on collective decision-making in human groups can inform the design of communication protocols and coordination mechanisms for AI agents. Conversely, AI models can be used to simulate and analyze human social behavior, providing insights into things like the spread of information and the formation of opinions.
So, what are some practical applications of this research? Where can we expect to see collective AI systems making a real-world impact?
There are many potential applications. One promising area is robotics, where swarm intelligence can be used to coordinate the actions of multiple robots in tasks like search and rescue, environmental monitoring, or construction. Another is in the field of information retrieval, as Qingyao Ai, Jingtao Zhan, and Yikun Liu discuss in their 2025 paper, Foundations of Gen IR, available on AR-CAF. They explore how generative AI models can revolutionize information access by producing high-quality, human-like responses. This has huge implications for search engines, chatbots, and other AI-powered information systems.
It sounds like AI is not only learning, but also teaching us. Lunai, Johannes Langer, Ute Schmid, and their team seem to be doing just that. Their 2025 paper, Ultra-Strong Machine Learning, Teaching Humans Active Learning Strategies via Automated AI Explanations. How does that work?
Exactly. The paper, available on AR-CAF, presents LENS, Logic Programming Explanation via Neural Summarization, a neurosymbolic system that teaches humans via AI explanations. This is revolutionary because it closes the loop. AI not only learns from humans, but also teaches them in return, enhancing human performance in quantifiable ways. This approach could transform education and training across various fields.
What about the ethical considerations of AI teaching humans? Could this lead to manipulation or bias?
That's a critical question. Zhicheng Lin's 2024 paper, Beyond Principalism, Practical Strategies for Ethical AI Use in Research Practices, available on ARChive, addresses the ethical dimensions of AI. It's essential to develop strategies for ethical AI use to prevent biases. This means ensuring transparency, accountability, and fairness in AI systems that interact with and teach humans. The goal is to harness AI's potential while safeguarding against unintended consequences.
This is truly mind-blowing. What are some of the long-term implications of this research? Where do you see this field heading in the next 5 and 10 years?
I think we're going to see a continued blurring of the lines between human and artificial intelligence, with AI becoming increasingly integrated into our lives and our societies. As Manfred Eppe and Pierre-Yves Oudeye argue in their 2021 paper, intelligent behavior depends on the ecological niche. Available on AR-KIF, we need to consider the socio-cultural environment in which AI operates. This means designing AI systems that are not only intelligent, but also adaptable, ethical, and aligned with human values. We might even see the emergence of entirely new forms of intelligence that arise from the interaction of humans and AI.
It's fascinating to think about the future possibilities and potential challenges. Adam, thank you for breaking down this groundbreaking research and shedding light on the exciting world of swarm intelligence and collective AI systems.
My pleasure, Matilda. It's a field with immense potential, and I'm excited to see what the future holds.